Today we are going to discuss about vertical circular motion of a mass tied to a rod. Here we have considered a massless rod, and to this rod a body of mass m is connected. The different forces acting here on the body are the tension acting at point A in vertically downward direction and the weight mg acting in vertically downward direction. Let O be the center of the circular path and R be the radius of this circle. The main difference in this case and in the case of the vertical motion of a mass tied to a string is that for the string some tension is required at all the points along the circular path. Even at the topmost point some tension is needed. But in case of the mass tied to the rod, as the rod is rigid, the condition is not needed and therefore the velocity at topmost point may be equal to 0. So this is the difference. At the bottom point, the different forces acting on the body are the tension Tb towards the center of the circle and the weight mg acting vertically downwards. So let us calculate the speed, minimum speed required at the bottom point B of this circular path. So for calculating Vb, let us use the principle of conservation of energy. According to this principle, the total energy at point A is equal to total energy at point B. So total energy is the sum of the kinetic energy and the potential energy at point A is equal to kinetic energy at point B plus potential energy at point B. The kinetic energy at point A is half m Va square plus potential energy is mgh, but h is equal to this r plus this r for point A. Therefore 2 mgr is equal to kinetic energy is here half m Vb square plus potential energy at point B is considered as 0 because point B is considered at ground level. So potential energy is 0 as H is equal to 0. Now here we have substituted Va is equal to 0. Therefore this kinetic energy is 0. Hence we get the equation 2 mgr, because this is 0, is equal to half m Vb square. Now this m cancels with this m, as it is 0, this will vanish, and this 2 goes to another side, giving us 4gr is equal to Vb square. So Vb is equal to under root of 4gr. So this is the important equation Vb gives us the minimum speed required in the case of mass tied to a rod. Vb gives the minimum speed required so that this system can complete the vertical circle. The motion along the vertical circle can be completed if and only if the minimum velocity at the bottom of this circle is under root 4 gr. Now let us calculate the velocity at point C. So for this, for Vc, now we shall derive the equation. Now the second equation for Vc can be obtained by again using the principle of conservation of energy. So we get total energy at point A is equal to total energy at point C. So it is again kinetic energy at point A plus potential energy at point A is equal to kinetic energy at point C plus potential energy at point C. Now kinetic energy at point A is 0, potential energy is 2 mgr, kinetic energy at point C is half m Vc square plus potential energy at point C with respect to point B is mgr. We have measured the distance from point B, that is bottom point. Point A is at a distance 2r and point C is at a distance r. Therefore, the equation becomes this. Now, when this mgr is transferred to other side, it will be minus mgr. So, 2 mgr minus mgr will give us mgr is equal to half m Vc square. Now this m cancels with this m, hence we obtain the equation 2gr is equal to Vc square. Therefore, Vc is equal to under root 2gr. This is the another important equation for velocity at midpoint in case of the mass tied to a rod. In case of string, Vc was equal to, it was calculated as equal to under root of 3gr, but in the present case it is under root 2gr. Vc is equal to under root 2gr. Now we have to find out the difference in the tension at point A and at point C. For calculating this, now we will form again the equations at point A and at point B. At point A, we are observing that the tension and the weight, they are both acting vertically downwards, and the resultant of the two produce the necessary centripetal force for circular motion. So at point A, we get the equation Ta plus mg is equal to m Va square by r. So we get at point A, the equation will be Ta plus mg is equal to m Va square by r. And at point B, what will be the equation for tension for the rather centripetal force? It will be Ta is in upward direction, means Tb is in upward direction, therefore Tb, and mg is in downward direction, So minus mg is equal to m Vb square upon r. Now we have to subtract the equation 1 from equation 2. If we mark this as suppose equation number 3 and this as equation number 4, then 4 minus 3 gives us Tb minus Mg minus Ta minus Mg minus Ta minus Mg is equal to m by r in bracket Vb square minus Va square. This gives us Tb minus Ta minus 2Mg is equal to m by r. Now Vb square as we have calculated is 4gr. So 4gr minus Va is 0. Therefore it will be 4gr. R will cancel with this. So Ta, this will be 4mg. Now we are interested in difference in the tension, that is Tb minus Ta. This will be this 4mg plus this 2mg. Hence it will give us 6mg. That is difference in tension at bottom point and at the top point again comes out to be 6 times mg, 6 times the weight of the body. So this equation is same as that for the mass tied to the string, but the equations for the velocity at the bottom, the minimum velocity rather at the bottom and minimum velocity at the midpoint in case of the mass tied to the rod are different. They are respectively Vb is equal to under root 4gr and Vc is equal to under root 2gr. So our next point is the sphere of death. Circus, we often enjoy the show of spear of death. It is called Mrityu Goal. So, initially, the bike rider performs motion along horizontal circle. The radius of the horizontal circle goes on increasing, then it tries to perform vertical motion and then exactly the vertical circular motion is performed by the motorcycle rider. We have here the different forces acting on the rider as n the normal reaction and weight mg of the bike rider. Here the normal reaction always act perpendicular to the surface of contact. The bike rider is in contact with the surface, inner surface of the sphere. Therefore, the normal reaction will act towards the center of the circle, and the weight mg of the bike rider is always in downward direction. For the lowermost position, the normal reaction will be normal to the surface, that is towards the center of the circle in vertically upward direction, whereas the weight of the bike rider will be in downward direction. This condition is same as the case of the mass tied to the string revolved in the vertical circle. Only the difference is that the tension in the case of string is now replaced by the normal reaction. The tension was in this direction, now normal reaction is in this direction. Here the normal reaction is now in the direction as that of the tension in case of string. Therefore, same equations will be obtained here also. Now, here one thing we should note is that V is equal to R omega. When the radius of the circle goes on increasing, then this velocity goes on increasing, but the angular speed goes on decreasing as the radius goes on increasing. This should be noted. Now, what are the different velocities so that the bike rider, the motorcycle rider rather, can complete the vertical circle? As usual, in the case of string, as we have obtained that the velocity at the top position must be equal to under root gr. At the midpoint, the velocity should be under root 3 gr, and at the bottom point, the velocity should be under root of 5 gr. So, same equations are applicable for the sphere of death. These are the minimum velocities needed so that the motorcycle rider can complete vertical circular motion in the sphere of death. So, otherwise, if the velocity is less than these values, then there is danger for the motorcycle. Now, we have to calculate the maximum speed of the vehicle when the vehicle is at the top of the convex overbridge. Here in the figure, I have shown the vehicle at the top of the convex bridge. The different forces acting on the vehicle when it is at the top of the bridge are the normal reaction, which is normal to the surface of contact, means it is in the vertically upward direction, whereas the weight of the vehicle acts in vertically downward direction. The resultant of these two forces, that is normal reaction and the weight, provides the necessary centripetal force for circular motion. Therefore, the equation becomes mg minus n is equal to mv square by r. V is the speed of the vehicle at the top of the bridge and r is the radius of curvature of the bridge. From this equation, it is clear that if n is 0, then and then only the speed can be maximum. Just to maintain the contact with the bridge, we write n is equal to 0. The condition is that n is equal to 0. Then the equation becomes mg is equal to mv square by r. M cancels from both the sides and we get v square is equal to rg or gr. So v max, that is the maximum speed at the apex or at the top of the convex bridge will be equal to under root of gr or rg. So this equation gives us the maximum speed with which the vehicle can be safely driven on the top of the convex overbridge. So thank you. Rest things we shall discuss in the next lesson.